Hello, let's do this question. I just did it. It took me way too long. I haven't submitted it yet, so I'm hoping it's the one. But my brain's not working. It's supposed to be a fairly straightforward question, but I slept late. Maximum non-negative product in a point matrix. Given a matrix, I want to find a path from the top left element to the bottom right element, such that the product of all the elements along the path give the maximum non-negative product. If it is negative, then return -1. We also take the answer modulo 10 to the power of 9 plus 7. Alright, so how do we do this? Well, we could do it using DP. Very DP heavy question. What would the subproblem be of the DP? It will be like dpi, dpj, be equal to the min. So we need to keep track of the min and the max, because the current max of any element could depend on finding the min of adjacent element. From each element, we can only move right or down, so it would either be the element above it or the element to the left of the current. So let dpij0 be the min product of elements, and dpij1 be the max product of elements. And this is the subproblem. Then we have a transition, which is really going to be the min over a bunch of stuff and the max over a bunch of stuff. What would they be? Well, it would be what the current element is, which will be ij, times the dp, and we consider all options. So it could be that previous row's min element, this could possibly give the min element, because if this is positive and this is negative, then we could get a candidate answer for this dp. And actually, there are 4 possible cases. So we consider the max of from the previous row, or from the current row, or the previous element from the current row, min and max. And do the same for here. Then the answer would be equal to the dp at I at the rows -1 and the cols -1, the max version. Turn something like if answer greater than less than 0, then return -1, otherwise return answer. Of course, we have to take care of the base cases, which is fairly straightforward. So let's give this a go. We actually don't need m times n space here. We can do it in all of m space, where m is the number of column, because we only need to keep track of the previous row. So let's have a previous min. This will be a vector of ints. What size would it be? Grid 0.size, so the number of rows. Let's initialize everything to 1. And let's have 4 of these. So we have previous max, current min, current max. Then we could go through all the elements, go through each element in a row. Now, what happens if we're at the first element? At the first element, the dp should be the grid's first element. So that's a special case where we need to say if I is equal to 0 and j is equal to 0, then just set the current min at j equal to the grid at ij. Here, current max would be the same, and then continue. Now we could keep track of these in an array, and then just use a stl function to find the min and the max, and set these. So let's call these candidate answers. Now I can only use the previous row if I is not equal to 0. So if I does not equal to 0, push back to the candidates grid at ij times previous min at j and previous max at j. If j does not equal to 0, then push back to the candidates current min at j, current max at j -1. And then I can set the current min to be equal to the min element out of the candidates, and the current max to be the max element out of the candidates. And at the end, say the answer is equal to the current max at the last element, which would be grid 0.size -1. And then return, if the answer is less than 0, return -1, otherwise return answer. Something along those lines. It should be can stop end. And this is an array, so it should be at j. And one more thing, I need to set update the previous min to be equal to the current min, and the previous max to be equal to the current max. Now I also need to make sure that the answer I return is modulo 10 to the power of 9 plus 7. So let's keep track of that as a const static mod equal to 1e9 plus 7, and then do this. Signed integer overflow. It says notice that the module is performed after getting the maximum product. They didn't really give a bounds on how big a number would be. So I'm guessing they just want me to use long. Type def long ll. And I don't think they want me to use modulus here, only after. Okay, this had to be ll. Okay, let's give that a run. Hopefully this time it works. Yes! Oh wow, that's... How could the space be that bad? Anyways, well, thanks for watching. Like and subscribe, and I'll see you in the next video.